Hi guys, this is Mr. Weber. Today we're going to talk about 3-4 notes on arithmetic sequences. So first of all, let's talk about what a sequence is. A sequence is a series of numbers that share a pattern. So for example, 1, 3, 5, 7, on and on and on and on. The pattern here is that we're adding 2 each time. That is a sequence. Today we're going to talk about arithmetic sequences and what that means. We'll define that here in a bit. So explore and reason. A fashion designer is designing a patterned fabric. We have the first row, second row, third row, fourth row, fifth row with a number of those pattern squares in the row. So we're going to complete this table. So row 1, here's row 1. We have one number of pattern squares in the row, and we also have one total number of pattern squares. For row 2, notice that we have 1, 2, 3 pattern squares in the row, and the total square patterns in the entire fabric would be 4. It includes the one above, so these 4. We'll do the same thing for row number 3. We have 1, 2, 3, 4, 5, which they already have written here, and the total number of everything above it, 5, 6, 7, 8, 9 total pattern squares. For row 4, we have 1, 2, 3, 4, 5, 6, 7 pattern squares in that row, and the total is all of them above. So 7 plus 5 plus there's 3 in this one plus 1. That gives us a total of 16 total number of pattern squares. And then finally, in our very last row here, row 5, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pattern squares in that row, and the total, all of the pattern squares in the entire picture that we see here is 25. So let's look for a pattern here. If we rewrote this, this would say 1, 3, 5, 7, and 9. This is a sequence that we just created. We're adding 2 each time. We add 2 to the previous number to get the current number. So it says, what patterns do you see in the rows of table? We just talked about it. We add 2 to each row. So today when we're talking about sequences, we're going to look for that difference, see what the pattern is, identify those patterns. Let's go on to the next page. Arithmetic sequences formula. So this is a new formula for us. So let's talk about how we would say this. So this says A sub n, the letter n, to subscript n, equals D times n minus 1 plus A subscript 1. Remember, we've talked about subscript before. When we have, for example, A subscript 1, that's just labeling that A. It has nothing to do with adding, subtracting, multiplying, or dividing. So in this formula, we need to know what each term means. So the A sub 1 term that we see in the formula right here, this is always represents the first term in the sequence. Okay. And then we have the letter D. The letter D in our formula is right here. D stands for the common difference in our sequence. Maybe we're adding 2 each time. Maybe we're adding 5 each time. Maybe we're subtracting 1 each time, so on and so forth. And finally, N, the letter N, is the number of the term we're talking about of interest. And you'll see in a second what I mean. So let's make a little note here, put a star. We can find the nth term. So nth term can be found by using this formula. So let's say we want to find the 27th term in a sequence. We can use this formula to get there quickly instead of writing out the entire sequence, 27 terms of the sequence. We use this formula to get to the 27th, for example, the 27th term very fast. So let's try it here. So we are given the sequence 7, 13, 19, and 25. And we are going to find a sub 19. Remember, 19 is subbed in for n, which is the 19th term in the sequence. So we need to figure out what the 19th term in this sequence. Here we only have 4 terms. And yes, we can continue this sequence and write out 19 of them to get to that 19th term. But let's do it a faster way and use this formula to find the 19th term. So in using this formula, we need to identify 2 things to start. We need to identify a sub 1. What is the first term in this formula? Well, the first term that we see, the first number in this formula is 7. So we know that a sub 1 is 7. And we need to identify D, or the common difference. How do we get from one term to the next in this formula? So from 7 to 13, we add 6. From 13 to 19, we add 6. And from 19 to 25, we add 6. So adding by 6 is the common difference. So D is just a positive 6. We're adding 6 to the previous term to get our new term in this sequence. Okay, so we are going to fill in a sub 1 where it goes in our sequence, and we're going to fill in D, which is 6 here. We're going to fill in those values of 7 and 6 for D and a sub 1. So we are given a sub n is equals D, which is, we know, is 6 times n minus 1, plus a sub 1. A sub 1 we figured out here for this sequence was 7. So all we did was fill in a sub 1 and D, the 2 things we found, to our arithmetic sequences formula. Now we need to simplify this formula. What do I mean by simplify? Well, this is 6 times that quantity, n minus 1. So we can distribute. We can distribute the 6. We draw our arrows and distribute. So we have a sub n equals 6 times n is 6n, and a 6 times a negative 1 is a negative 6, but we still have a plus 7 attached. So we're really close to finalizing this formula now, but we can still combine like terms. We look for like terms here. Well, I have a negative 6 and a positive 7. Those are both constants, so I can combine them. Negative 6 plus 7 gives me a plus 1. So we have 6n plus 1 is now our formula. So we're almost there. This is the formula that represents this sequence. A sub n equals 6n plus 1 represents this entire sequence. So now we can use this formula to figure out whatever term we want to find. So here we need to find the 19th term. So we're going to use this formula to find the 19th term in this sequence. So I will say to find the 19th term, this is what we do. We use our formula. We will plug in 19 for the letter n, because n, if we remember, represents the number of the term we are trying to find. So we're going to take this formula, and anywhere we see an n, we plug in the number 19 for the 19th term. So this will become a sub 19, which represents the 19th term in this sequence, equals 6 times n, but we know n is 19, plus 1. And now we simplify this. So order of operations, we have 6 times 19 plus 1. We do multiplication first, so 6 times 19 is 114. And then we have a plus 1 still, so a sub 19 equals 114 plus 1, and 114 plus 1 is 115. So the 19th term, a sub 19, in this sequence is 115. Give you guys a second to make sure we have all that written down. Again, we started with identifying a sub 1 and D. We plug in our a sub 1 and D into our formula. We simplify our formula, and then we plug in what term we're trying to find. We tried to find the 19th term, so we plug in 19 for n and simplify to get that 19th term. Let's do the same thing for this next one. We're given a new sequence, 30, 26, 22, and 18, ... Now we're going to find the 8th term in this sequence. So it is exactly the same exact steps. So we need to find a sub 1, and we need to find d, the common difference here. So our formula, again, is a sub n equals d times n minus 1 plus a sub 1. Let's find a sub 1. Well, a sub 1 is the first term in our sequence, so we know a sub 1 is 30. And we need to find d, the common difference. How do we get from 30 to 26? Well, we subtract 4. How do we get from 26 to 22? We subtract 4. How do we get from 22 to 18? We subtract 4. So our common difference, if we subtracted 4, becomes negative 4. And we plug in a sub 1 into our formula here, and we plug in d into the formula here. So this becomes a sub n equals negative 4 times n minus 1 plus our a sub 1, which is 30. Now we simplify this formula. We need to distribute this negative 4. So we get a sub n equals negative 4n plus 4, and we attach that plus 30. Now we're at the point where we can combine like terms. I have a positive 4 and a positive 30 to combine because they are constants. So we are left with a sub n equals negative 4n plus 34. So this is the formula that represents the sequence that we were given. But we need to remember, we're trying to find the 8th term in this sequence. So to find the 8th term, we plug in the number 8 for n in this sequence. So we will say a sub 8 equals negative 4 times n, but we know n is 8. We're trying to find that 8th term, plus 34. So a sub 8, we simplify this, negative 4 times 8 is negative 32 plus 34. So negative 32 plus 34 is 2. So the 8th term in this sequence is 2. Give you guys a second, make sure we have all of that written down. And let's go on to the next page. Okay, how can we tell if a sequence is arithmetic? We can tell if there is a constant, underline that word constant, common difference. So we've already found common differences, but that common difference has to be constant for the entire sequence. It cannot change. If it is constant for the entire sequence, then it is an arithmetic sequence. If it is not constant, it is not an arithmetic sequence. So let's practice that here. Tell whether or not each sequence is an arithmetic sequence. So we need to find our common difference. To get from 1 to 3, we add 2. From 3 to 5, we add 2. And from 5 to 7, we add 2. Do we have a constant common difference? Do we add 2 every single time? Yes, we do. So what is our conclusion? That this is, yes, it is arithmetic. And we can write the common difference. D is 2. For B, again, same thing. We need to identify if there is a constant common difference. So how do we get from 4 to 12? Well, we add 8. How do we get from 12 to 20? We add 8. And how do we get from 20 to 28? We add 8. Is there a constant common difference? Do we add by 8 every single time? Yes, we do. So our conclusion is yes, it is arithmetic. And our common difference, D, is 8. Finally, for C, identify the common difference. To get from 70 to 75, we add 5. From 75 to 80, we add 5. From 80 to 86, we add 6. So that changes things for us. We do not have a constant common difference. We add 5, and then we add 6, which changes it for us, changes that common difference. So this would be not arithmetic. We have no constant common difference. Our common difference changes. All right, on to the last page. Number 1, the essential question. How are arithmetic sequences related to linear functions? Well, we've already talked about. Let's start with arithmetic sequences. They give us constant common differences. That's exactly what we just talked about. It has to be constant. And with linear functions, what is constant about linear functions? If we think of the graph of linear functions, they are always a straight line graph, which means that the slope has to be constant for any linear function. So that's how they are related. We have constant common differences for arithmetic sequences. For linear functions, the slope is always constant. Both deal with that word constant. We're going to skip 2, we're going to skip 3, and we're going to skip 4. Okay, I want you guys to try 5 and 6 on your own. They are exactly like these 3 examples that we just did on the last page, so you can pause the video right here, give 2 or 3 minutes, try 5 and 6 on your own, see if there is a constant common difference to figure out if these sequences are arithmetic or not. So go ahead and pause the video here. All right, so let's do 5 and 6. Let's check your work. Let's figure out the common difference for 5. So from 15 to 13, we subtract 2. From 13 to 11, we subtract 2. And from 11 to 9, we subtract 2. Do we have a constant common difference? Yes, we do. We subtract 2 every single time. So our answer is yes, this is an arithmetic sequence, and our common difference D is -2. For 6, how do we go from 4 to 7? We add 3. From 7 to 10, we add 3. But from 10 to 14, we add 4. So this is not arithmetic. We do not have a common difference. We add 3, and then we add 4, which changes that common difference. Okay, let's do 7 and 8 together to finish these notes. It says, write a formula for each sequence. Remember, our arithmetic sequences formula is this. A sub n equals D times n minus 1 plus A sub 1. So we've already done a couple of these. We need to identify what A sub 1 is here, the first term in the sequence. Here it's 81. And we need to identify D, our common difference. How do we get from 81 to 85? We add 4. From 85 to 89, we add 4, we add 4, and then we add 4. So this is an arithmetic sequence, so we can write this formula. So our common difference is 4. Now we plug these in, A sub 1 and D, into our formula. So we will say A sub n equals D, which is 4, times n minus 1, and we plug in A sub 1. So plus A sub 1, we know A sub 1 is 81. Now all we have to do is simplify this formula. So we distribute the 4, draw our arrows. 4 times n is 4n. 4 times -1 is -4, and we attach that 81. Now we can combine like terms. This -4, -4 plus 81. We can combine those two things because they're both constants. So -4 plus 81 gives us 77. You can use a calculator there if you need to. So we're left with 4n plus 77. That is the formula that represents that sequence. And all it asked us was to write the formula. It did not ask us to find a specific term in that sequence. Okay, now I want you guys to try number 8 on your own. So go ahead and pause the video here, do the same exact steps we just did in number 7. Identify the first term in your sequence, identify your common difference, plug them into the formula, and simplify. Okay, go ahead and pause the video. All right, let's check your work, see if you are correct. So we need to find the first term in the sequence, which here is 47, and the common difference. So from 47 to 39, we subtract 8, subtract 8, subtract 8, subtract 8 for all of these. So our common difference is -8. We plug in A sub 1 and D to our formula. So A sub n equals D, which is -8, times n minus 1, plus A sub 1, which is 47. And we distribute, to simplify this formula, we distribute that -8. So we get -8 times n is -8n. -8 times a -1 is a +8. And we attach that 47. Here we can combine like terms. We have a +8 and a +47 that are constants that we can combine. That will give us 55. So we have negative 8n plus 55 is our formula that represents this sequence. And we are skipping 9. All right, that is it for today. Thank you, everybody.